This is Advanced Math 1.5 notes. That's Unit 1, Lesson 5. And we're going to be simplifying complex fractions. And if you don't remember, complex fractions are fractions within fractions. Number 1, 7 over x plus 1 plus 3 over x minus 2 all over 4 over x minus 2 minus 3 over x plus 1. Okay, things you cannot do. You can't, again, just willy-nilly go around canceling things. It does not work that way. What you're going to do is try to clear the complex fraction. So we need to clear the complex fraction, meaning we want to get rid of the fraction within a fraction. We just want one plain fraction, not these little bitty fractions within. And how do we do that? We multiply everything by the common denominator. Multiply everything by the common denominator. Okay, so what we do is we look at all four, 1, 2, 3, 4, and we look at the common denominator. They have an x plus 1, so I need to multiply by an x plus 1 to be able to clear that. So I'm going to multiply everything by an x plus 1. And they also have an x minus 2 that I need to clear. Even if only one of them had the x minus 2, that would still be part of the common denominator. Okay, so I'm going to multiply by x plus 1, x minus 2. Now, you don't have to put it over 1. I'm just doing that to show that I'm multiplying itty-bitty fractions everywhere. I'm pretty much distributing this x plus 1, x minus 2 to every term. Okay, x plus 1, x minus 2, and we are going to clean things up and reduce. Okay, so what reduces here? The x plus 1 reduces, gone, and I distribute the 7 to the x minus 2, and that gives me 7x minus 14. Okay, next piece, I cross out reduce the x minus 2, and I distribute the 3 into the x plus 1, and that gives me plus 3x plus 3. I'll clean up like terms at the end. All right, down in the denominator, I'm going to reduce the x minus 2, and I'm also going to distribute that 4, leaving me with 4x plus 4. Now this part's a little tricky. You'll want to be careful. When you reduce, that is perfectly fine. But a common mistake kids make is they'll say, oh, minus 3x minus 6. And that is incorrect. Be careful. What you're distributing here is not just a 3, but you're distributing the negative 3. So it would be negative 3 times x is indeed negative 3x. Negative 3 times negative 2 is positive x. So be careful with that negative. Up here we didn't have to worry about it too much because it was a positive. But here it is a negative. So be careful is all I'm saying. All right, we're going to combine like terms, giving me 10x. And there I get negative 11 over, that is 1x. And here I get positive 10. And there's no more factoring that can be done, and I cannot reduce anything. This is my final answer. All right, we'll do more of these in class. I'm going to move on. Number 2. 2 over x all over 2 over x plus 1. I'm going to scooch that over just a smidge. 2 over x plus 1. All right, it's going to look like this. Now, because it's a single fraction within a single, just a single fraction at the top, a single fraction at the bottom, you could multiply by the reciprocal. I'll show you that in a little bit. But right now, I want to show you how to do it the way we did the last one. We multiply everything by the common denominator. So I'm going to multiply the top fraction and the bottom fraction by x and x plus 1, because that is my common denominator. X and x plus 1. Okay, let's reduce. X is gone, distributing the 2, giving me 2x plus 2. The bottom, the x plus 1's reduced, leaving behind a 2 and an x, and that is simply 2x. Now, if you stopped here, there is a chance you could get it wrong because I don't know if I can reduce. So I have to factor up here with the GCF. That leaves behind x plus 1 all over 2x, and then you reduce. 2's are gone, leaving behind x plus 1 over x. Okay, and next one over here, I'm just going to show you what if you wanted to multiply by the reciprocal. You don't have to do this one, I'm just going to show you it would work. Now you could only multiply by the reciprocal when it's one fraction at the top and one fraction at the bottom. So it would not have worked up here on this one because there were multiple fractions. On either one, you cannot do it. Okay, so it would be 2 over x times x plus 1 over 2, because you're multiplying by the reciprocal. The 2's reduce, leaving behind x plus 1 over x, which is the answer we came up with. So again, this shortcut you can only use when it's a single fraction within a single fraction. If you think I'm not going to remember that, then don't ever worry about it. Just do them all the same way. And that is multiplying everything by a common denominator. All right here in this space, I'd like you to write your favorite animal. Write it down. Mine would be a giraffe. Write it down, an elephant, a dolphin, whatever it may be, doggies, kitties. You're just writing it down. Okay, I am moving on, and I will be looking for it, so make sure it's there. Number 3, x plus x over y all over negative y plus 1 over y. Now, what I would suggest on problems like this is the first thing to do, make everything a fraction. If it's not a fraction already, make it. I'm going to flip this over really quick. You see 1, 2, 3, 4. We had 4 fractions. 1, 2, we had 2 fractions within the big fraction. Here, I have 1, 2, 3, 4, but these two don't look like fractions. Now, you don't have to, but it's easier on the eyes if you can see everything as a fraction. Okay. We're just going to clear. I cannot multiply by the reciprocal because there's more than one fraction. So I'm going to multiply everything by your common denominator. Think about what it is. And I'm hoping you realized it is y. And I like to put them over 1. It's not necessary, just to show that it is a fraction. And I am going to, nothing reduces here, so it's xy. Y is reduced, so plus x. It looks like I can take a GCF out there. Okay, here is nothing reduces here, so that's negative y squared. Reduce plus 1. All right, I can take a GCF out at the top. Now I can't reduce the y's, but I do have to factor just in case anything reduces. If you factor and nothing reduces, no problem. But if you don't factor and something would have reduced, then you would get it wrong. So GCF, and I can see this, I'm going to think about it as 1 minus y squared. And I'm going to rewrite it as 1 minus y squared so I can, difference of 2 squares. 1 plus y, 1 minus y, and we are going to reduce. Now, look at these guys right here. These are not opposites. Y plus 1, 1 plus y. They're not opposites because there's plus signs in the middle. If it had been y minus 1 and 1 minus y, then they would be opposites and you would reduce and put a negative in the front. Since they are not opposites, they are exactly the same. They're just flipped around, and that's okay to do that on an addition sign. Addition is commutative. So I'm just going to simply reduce them, not taking out any negative. X over 1 minus y. And that there is your final answer. Okay? Now, really quick, just a side note, if you're ever taking a multiple choice test and you see it written like this, just know it's the same thing. You don't have to do this. I would be perfectly fine with this answer here. But just know it's the same thing. What was done between these two, a negative was taken out of the bottom and moved to the top. And if you factor out a negative out of the bottom, it gives you a positive y and a negative 1, and the negative moves up. Again, just, I'm fine with that. But no, that's the same thing. If you're ever taking a multiple choice test and you don't see your answer, but you see that, don't freak out. Oh, that's the same thing. And you mark it, you get it right, and you're happy. All right, number 4. 1 over x squared minus 1 over 25 all over x minus 5. Now, I put parentheses there. Technically, they weren't supposed to be there. It's okay if you leave them. If you're writing in pen, it's not a big deal. I'm going to put them back in pencil in a little bit. I just want to show you what it's going to look like on your assignment. Okay, a big common mistake kids make on something like this, so please listen and be careful. When they find their common denominator, they'll say, oh, it's 25, it's x squared, and the x minus 5. Be careful. It's not 25x squared x minus 5 because this here is not a denominator of its individual fraction. I can do this, and 1 is underneath. Remember when I said earlier, make everything a fraction? Fraction, fraction, that is a fraction. It just needs the 1 underneath. Now, if you wanted to, you could put x over 1 minus 5 over 1. You can make individual 2 little fractions, so there's 2 at the top and 2 at the bottom. But I'm just going to make 1, and it doesn't matter. It works both ways. All right, now looking at it the way it should be, my common denominator is only 25x squared. Again, it is not the x minus 5 because the x minus 5 needed a 1 underneath. Okay, so we are going to reduce. X squared is gone, leaving behind a 25, minus 25 is gone, leaving behind an x squared. And then nothing reduces here, so 25x squared. I'm not going to distribute that 25x squared. The reason not is because I'm going to want to reduce later, so I want to leave it in factored form. On the previous page, why did I do all this distributing then? Was because I wanted to be able to combine like terms. So I distributed the 7 so I can combine like terms. I distributed the 3, again, so I could combine like terms. I distributed the positive 4, the negative 3, so I could combine like terms. Here, there's only one fraction at the bottom. Distributing the 25x squared is not going to allow me to combine like terms, so I'm not going to distribute. If you did, that's okay. You're just going to factor it at the end. You just have one extra step. Okay, at the top, it's difference of 2 squares backwards. I'm just going to factor it backwards. If you wanted to, you could flip it around, take out a negative and factor, but I'm going to factor like this. 5 plus x, 5 minus x, 25x squared, x minus 5. And these are opposites because there's a minus sign in the middle, positive 5, negative 5, negative x, positive x. So when I reduce, I pop the negative out front. I always put it out front at the top. Technically, it could be at the bottom if you wanted to. All right, so then that gives you negative 5 plus x over 25x squared. Okay, again, different ways you might see this on a test. A test writer might write it like this: 5 plus x, the negative sign right in between 25x squared. That is still correct. You don't have to write it this way. I'm just showing you possible ways you'll see it on a test. A test writer might put it at the bottom. Typically not, but they could. A test writer might distribute it. Negative 5 minus x, I get over 25x squared. Again, these are just different ways. I'm perfectly fine with you stopping here, but if you're taking a test, a multiple choice test, and you don't see your answer, look for other ways it might be written. All right, that is it for this lesson. We'll go over more of these in class.